So we were covering diff and diff. We're going to cover it again today. What we're going to be doing is the event study. We're going to discuss a paper, and we're going to go through the Goodman-Bacon decomposition. Then we're going to do a simulation together, and then we will do the Callaway and Santana. We will redo the simulation, and then I have made available R and do files for the simulations. You can go ahead and pull from GitHub. And then we're gonna take a existing data set, and we're gonna try to just replicate a few of the group time average treatment on the treated from Callaway and Santana. We'll do the Goodman-Bacon decomposition. We'll sort of look through this paper a little bit more in detail. And so I anticipate diff and diff will take probably most of the day. We start synthetic control tomorrow, and then, we'll have some time for matching. All right, so let's go ahead and start. All right, so the nature of the diff and diff, as we said, is the randomized, parallel trends assumption. And remember, the parallel trends assumption is a counterfactual assumption. So it looks like this. Just as a reminder. Okay, sorry, this is taking so long. Here's the parallel trends assumption. And if this is not zero, it's non-parallel. And when you estimate the ATT, it will be biased. We've got this counterfactual state of the world minus the observed state of the world, and then the observed state of the world minus the observed state of the world for the control group. Okay, so let's look at that. So what's done? Since it is untestable, what is typically done is the event study. Now, the thing is, the event study can be done with one group with a simple 2x2, but just plotting the data or residualizing the data after applying the Frisch-Wall level theorem or the regression anatomy theorem to the raw data. You can parse out all those covariates, and you can just plot that. You just see if your group here, this is the control group, this is the treatment group. If they're similar in the pre-treatment period, ergo they would have, the argument is if they're similar here, then they will be similar down here. Okay. All right. So, but that ends up running into problems if you have a control group. You have two control groups who are treated at different points in time. What happens is that one of the controls both of the controls if you have two treatment groups and one control, or any controls with multiple treatment groups, the pre-treatment period it's not very clear, what it is. How can it be if the treatment period is 92 for one, New Jersey, and the treatment group is 93 in another? What does it mean to be pre-treatment for Pennsylvania, right? Is it 1991 or is it 1992? Well, we're going to get more into that with Goodman-Bacon, but originally what we're doing is we're looking through what did people done? What had people done before? There was two things that they did before. First of all, what they're wanting to do is the event study, not the event study in finance, but the event study in economics, where what you would do is you would just simply plot the differences in the treatment group and the control group in the pre-treatment period. You can see right here that it looks like these controls states look like the treatment states. But remember, this is differential timing. These are like a group of states that pass legislation at different points in time. And now you can get -1s, -2s, -3s on them and average them. But how are you getting these control states? Because we just got finished saying that when you have differential timing, the control states have undefined pre and post treatment. So you don't know what a -1 is for Pennsylvania, because there's multiple, that -1 is always with respect to a treatment group. So what Anderson, Hansen, and Reese did was they randomized treatment dates to the control groups and just simply plotted it. Now, in this case, it looked like it turned out pretty well. But what's weird is that technically that's just visual. That is not what the regression is going to use for any of its estimation. So what's more commonly done is excuse me, is event study data. So here's what I did. I was looking at average birth rates as the website Craigslist personal section entered communities. The personal section was basically units, or it was a part of the website where you could meet someone romantically. So we were wanting to know, it was like an early alternative to OkCupid or Tinder. What was nice about it was it rolled out at different points in time. Well, here I am using the same kind of approach with the control states as Anderson, Reese, and Hansen. It's kind of so seasonal, it's hard to see though. So what I did instead was what would be used for the regression. I did the event study regression. And what you're doing in the event study regression is you've got your state, you've got your two-way fixed effects, maybe you've got some covariates, and then you've got leads, the dummy on the diff and diff and the pre-treatment periods, one by one, and then in the post-treatment period, okay? Now, when I ran that, the results look very different because what you were originally wanting to see was you were wanting to see a bunch of zeros right here and then a decline. That's not what we saw. And so, you know, what I experienced from doing this was pessimism that that my estimator worked, or that my model was picking up parallel leads, which I thought, you know, if you can't pick up parallel leads, then no one's going to believe my result. Okay, I'm going to come back to that. So I wanted to show you. I apologize, I keep yawning. I can't seem to stop yawning. So I want to show you what a really good picture looks like. This event study. Now, this one is not differential timing. This is a collection of states in the United States that expanded Medicaid under the Affordable Care Act, Obamacare. Now, remember with that Oregon Medicaid experiment, we were finding no effects on mortality. I didn't even cover it. I just said we found no effects on mortality. But it could be that that was like, you know, Oregon's different. It could be that not enough time had passed. It's not really clear. Okay, so Miller et al., they examined the rollout of Medicaid under the Affordable Care Act by linking that Medicaid data with administrative death records. They had all the people that were on Medicaid, and they had whether or not they passed away. And so they find doing that a 9.3 reduction in annual mortality caused by Medicaid expansion. And it's coming from a reduction in disease-related deaths, which got larger over time. So look, here's the argument that they're going to make, okay? What they're going to do first is they really need to show a first stage, okay? So they look here what they got. So they've got Medicaid eligibility. This is the proportion of the population eligible for Medicaid. And you can see that the states that passed and the states that didn't had very similar levels of Medicaid eligibility. And then afterwards, there was about a 40 to 45% increase in Medicaid eligibility after the expansion, which is what we expect because by definition, it mechanically was like that. We also looked at the effect it had on Medicaid coverage. Now, Medicaid coverage would be the number of people on Medicaid, or the probability that they were on Medicaid. And you can see right here, they were similar before. 1, 0, 1, 0, a couple off. That's just our baseline estimate. And then there's a large increase in people on Medicaid. Now, maybe what's going on is people are just switching from private insurance to public insurance, but in fact, they're not. You don't see evidence of switching. It looks like it's just simply, or at least it's a non-trivial number of it, is actually a reduction in people not having any insurance altogether. So having showed that there was this really large effect, they then moved on to the proportion that passed away. Now, this is more common, the sort of picture that you'll see with these event studies. We have 1, 2, 3, 4 that are basically 0, and this one right here, which is not a 0, but it's not statistically significant from 0. It's not statistically different from 0. So See right here on that side, you know, it's kind of these four are basically zeros. And then afterwards, it fell, okay? So you're finding here that the states that expanded saw, after they expanded, declines in mortality of those people that were on Medicaid, okay? So it's a really important study because it helped give some additional credibility beyond the RCT that, in fact, yes, there was going to be meaningful reductions in mortality, 9.3 annual mortality reductions, and as a result of that, might be cost effective, given a statistical value of life of like $10 million. So many people use DD strategies using data for many years. They don't just have a one period pre and a one period post like David Card and John Snow did. Variables of interest in many of these setups only vary at a group level, say the state level, and outcome variables are often serially correlated. So Bertrand, Duflo, and Mullinthan point out that conventional standard errors often severely underestimate the standard deviation of the estimators, meaning that heteroscedastic robust standard errors are biased. They're biased downward. They're going to be too small. You're going to over reject. So they had three solutions that they recommend. First, they recommend block bootstrapping. Block bootstrapping is you're going to analyze the states with you're going to analyze states where the block should be the states. You would sample whole states with replacement for bootstrapping. So you're going to just basically go through, partition the data. You're going to grab 50%, 20% of the data, run your regression, do that 1,000 times, get a standard deviation. That's going to be your standard error. Okay. The second, I've never seen anybody do that. Okay. Second is you could cluster your standard errors at the group level. In Stata, that would simply be comma cluster state to the regression equation if you want to analyze state level variation or city or country. Okay, now that is the most common, definitely the most common solution that people do, because as you can see right there, there's very little programming that's involved. Versus this aggregation method, which is a very unstrange method, and I've definitely never seen anybody do it. I've tried to do it myself, and I am still learning about it. Basically, what you do, you aggregate the data into one pre and post period. This literally only works with one treatment date. But if you have staggered treatment dates, then you have to run a series of regressions, or a regression, and get residuals. And then you have to do differencing off the residuals. So you're going to regress Y on this to two-way fixed effects and estimate covariates. You're then going to get the residuals, but only for the treatment group. And then you're going to divide them into two groups, the post group and the pre-group. Now, since it's differential timing, that means the post group differs year to year and the pre-group differs year to year, but that's okay. Then you're going to regress the two groups of residuals onto a post dummy, but you're not going to use the residuals from the control group. And I'm still sort of trying to figure out the theory of this. They don't really explain it. Andrew Goodman-Bacon has told me that you're getting the same, when he decomposes this method, you're getting the same decomposition that you get from diff and diff, only with a scaling factor. So that was kind of interesting that you're getting that. And then, so you could just rescale the data by that scaling factor. And I believe you should get a result that's very similar to what you're getting here in number 2, but with corrected standard errors. So sometimes when you have very small errors, small number of treatment groups or small number of groups, either one of those, then the standard errors are going to be, again, too small for different reasons, because you have a small cluster problem or you have just a small number of treatment groups. So what's been suggested for those situations, when it's too few of groups or too few of clusters, they recommend the wild bootstrap. But when you are working with too few of treatment groups, it's oftentimes they will recommend randomization inference or the Conley and Tabor correction. All right, so let's talk about robustness. Just like we did with RDD, there's lots of robustness checks that are done. So it's very common for that to see the place. Now we're going to talk about 3 kinds of robustness checks. First is the event study, which we discussed. Second is an alternative control group. Third is a falsification test that uses alternative placebo outcomes. It shouldn't be affected by the treatment. Let's go one by one. All right, so the first thing we're going to look at is triple difference. Let's say that we had high wage and low wage employment in New Jersey. We have high wage and low wage Pennsylvania employment. Okay. Now, inside the low wage group, we think that the minimum wage is likely to affect this group and only this group. It's probably not going to affect our wages because we are far above the binding minimum wage, but for these low wage groups, it could matter. Okay. So then we have the state fixed effect. We have the time fixed effect. We have a time dynamic New Jersey fixed effect. We have a low skill trend. And then we have the treatment effect itself. So I'm going to do before and after minus before, and I get rid of the fixed effect, and I get T plus NJ plus LT plus D. Then what I'm going to do, since I did it again for my control group, I'm going to then subtract this from this, and look what I get. I get T cancels out, NG cancels out, and I get L minus S plus D. Now look, this is our not selection bias, but it's like, well, it is. It's selection bias, but it's basically, yeah, that's what it is. It's the selection bias. It's the difference between the low skill work in a world where they're not given treatment minus the high skill work in a world where they didn't get the minimum wage. Okay, and that is, let me write that down. Okay, so this is basically expectation delta equals ATE plus LT0 minus ST0, right? And that is selection bias. So we need a control group for selection bias, which we have down here after we've gone through the same steps, okay? Yeah, Sebastian asked, are we assuming a kind of parallel trend? We're assuming that the time effect for high wage and low wage were equal. Yeah, we are assuming, let's see, Sebastian, what are we assuming? So we're assuming a parallel trends assumption, which is actually right here, the LT minus ST. We're basically saying, because it needs to be a function of T for it to be parallel trends. And what we're basically saying is that LT is the same for both groups and ST is the same for both groups. Right? So we've got two parallel trends. We need LT and ST to be the same as opposed to just T. We're netting, and so you need T to be the same for the high and low wage group. You need NJT to be the same for the high and low wage group. And then you've got unique national trends. You've got unique national trends for low wage and high wage groups. So yeah, the problem is triple diff does not allow you to get assumption-free identification. You're going to get identification off of the belief that you have these two parallel trends that are holding, both of which, this one right here is observable, this is not observable, okay? We need the distance between LT and minus ST to be the same per year for the treatment group and the control group. And again, you could do a triple diff looking at the event study to see what it's like on the pre-treatment period, but you would still, have to be making more assumptions. So thank you, Sebastian. So when you do that, and assuming that it is the same, then this will cancel out and this will cancel out, and you'll be left with the average treatment effect, which is here, or the average treatment on the treated, technically. So this was developed by John Gruber. If you remember, John Gruber was one of the authors on the Oregon Medicaid experiment. He was the architect of the Affordable Care Act, Obamacare, in the United States. And he did a study where he was wanting to know the effect of state laws that mandated that physicians provide maternity benefits to pregnant women. And what he wanted to know was, did it lead to a reduction in wages? Because with those rules, basically women who were married age 20 to 40 would be able, they would basically be able to be paid less in order to like create a compensating risk premium. All right, so what do? They have married women, 24-year-old. That's the treatment category because these women are of childbearing age. So we're going to go after minus before. It's going to give us a negative 0.34. We're going to do after minus before for our never treated states, 1.397 minus 1.369. We're going to get 0.28. Then we go negative 0.34 minus 0.28. So that's going to get us up to negative 0.62 for the standard error. And it's very precise. All right, but maybe you believe that parallel trends doesn't hold at that level, but you think it might hold here, okay? So you're going to look at women over 40, single males 20 to 40. Neither one of those women, neither one of those workers will likely be affected by state mandates because men never leave the labor force when their family have children, and people over 40, I believe it's women, are not they are not at risk to have a child. So he does those, okay, and their results stay the same, right? Negative 0.11 as opposed to this negative 0.34, negative 0.03 as opposed to this 0.28. Then we subtract those, this minus this. We get negative 0.08 off the diff and diff, and then we subtract this from this. And we get our triple diff, negative 0.54 with a standard error of 0.26. So you can see right here the triple diff can be done the same way as we did the other one. You don't need an event study. But if you did, you don't need a regression. But if you did a regression, it would be kind of complicated. Because basically what you've got to have is you've got to have dummies for the treatment states, and then you have to have dummy for the treatment and control individuals, which means you're going to have to stack the data vertically such that for every state, you also have a group of married 20 to 40-year-olds and unmarried men and people over 40. You're going to have to do both of those. All right, so how do you do that? Now, I put all of the interactions in here, but one of them is going to drop out. So you're going to have a post dummy, a group dummy, so that would be the treatment individuals, and a state dummy. A state dummy measuring the treatment groups that is going to be treated. Then what we've got is delta times t. All right, delta times t. And that gives us the group J interacted with a time trend. We're going to have the time trend interacted with a state trend. We're going to have the group trend interacted with the treatment state. And then once we have 1, 2, 3, 1, 2, 3, one of those is going to be dropped. We're going to interact all three with each other, and that's going to give us beta 8. And so beta 8 is the triple difference estimate using OLS. Now what you're wanting is when you do this, you want to look at your diff and diffs and try to compare them with what you're finding in beta 8. You really want it to be that you're finding negative effects or positive effects on the treatment group and finding 0 effects on the placebo group. That tends to be what makes people be a little bit more persuaded. So if you did a diff and diff here and it was a 0 on the treatment group, but you did this one and it was a negative 0.54 on the control group that's not even getting the treatment, people tend to be a little skeptical because it's basically saying the control group is what's causing this as opposed to the treatment group. So what we're going to do is we're going to discuss one of my papers from the third chapter of my dissertation, looking at abortion legalization's effect on long-term risky sexual behavior. And I'm going to provide a do file. I'm not going to replicate it. I just want to show it to you, okay? So this is the paper. This is with my advisor, Chris Cornwell. It was the first paper in economics that I published. No, it wasn't. My first was in something else. Okay, so what's the motivation? Legalization of abortion was found to reduce teenage childbearing by 12%, 12 percentage points, which is a very large effect. Jonathan Gruber, again his name, Jonathan Gruber showed that the marginal child aborted would have been 60% more likely to live in a single-parent household, 50% more likely to live in poverty, and 40% more likely to be a recipient of public services. The mechanism for these things was believed to be non-random selection associated with high-risk conditions. What does that mean? It's believed to be that the marginal child that was aborted was poor, okay, at least in the early 70s. Now, Donahue and Levitt, John Donahue and Stephen Levitt wrote the John Bates Clark Award, or he won the John Bates Clark Award. They linked abortion legalization to declining crime in the 90s. Right, so they were saying, look, abortion legalization, just as it reduced people that lived in poverty, because the marginal child aborted would have grown up in poverty, they would have also grown up at risk and might even have committed crimes. Okay, so they write that. They find very large evidence that it reduced crime. And then they wrote a book called Freakonomics, and it became a very big bestseller. It's not the Levine one, Francisco, that gets critiqued. It's actually this Levitt one. I'm going to get into the critique in just a second. So other papers followed Kerwin Charles. Other papers followed that followed that paper were Kerwin Charles and Melvin Stevens' 06 Journal of Law and Economics. They found that children exposed in utero to legalization were less likely to use illegal substances. So like for a brief period of time, and then there was another one in another country, for a brief period of time, there was a lot of interest in it. But then there was controversy, which Francisco sort of alluded to. First, there was a couple of papers by Ted Joyce in the Journal of Human Resources and Review of Economics and Statistics. One of them was a triple diff by Joyce in the Review of Economic Statistics, finding no evidence for abortion legalization or crime. What he did was he used a triple difference design where he used as his second group the states that were above the median in terms of abortion rates in the early period. So he did that, he finds no effect. But the real fatal paper is by Foot and Getz, and that shows up in the Quarterly Journal of Economics. I believe it was the QJE, it may have been the Aeon. What they do is they argue, well, there's actually several problems, all of which are all of them are technical problems. One is he doesn't use a diff and diff. Levitt and Donahue don't use a diff and diff. Instead, what they use is what's called the abortion ratio. So it was just a panel regression with on the right-hand side was an abortion ratio. It was the sum of all abortions by year divided by the number of births per year. It was kind of a complicated variable, particularly since births was in the denominator and was endogenous to the abortion legislation in the first place. So they corrected it. They said it was mechanically tied to declining crime rates. And then they found a coding error where they said they included state year fixed effects, but in fact had not included state years fixed effects. And when you did both of them, the effects went away. If you corrected the state year fixed effects, the results only marginally worsened. It was not, but that's the thing most people remember it for, was like a coding error. That was not actually what seemed to me to really destroy the results. What destroyed the results was correcting the abortion ratio. And when you did that, you found no effects. At that point, the literature stops. There is no subsequent papers on abortion and crime or abortion and anything until my paper. All right. So I want to say one thing to remind people. Levitt always gives his data in his do files. The only reason that we found a coding error was because Steve Levitt posted his do files to his website, and he gave them to anyone who asked. And I'll tell you right now, it is very easy to lose do files. You can say things like, I've had many computers that have changed. You can't find them. Or you can say, I can't share the data, or you can do all kinds of stuff. Levitt, in my opinion, had tons and tons of scientific integrity because he's always been willing to cooperate. And many people who have probably gotten coding errors, and they'll just refuse to share. Increasingly, journals require it, but it's not universally required, and it has its own. But this, this was purely voluntary. So I've always been like really impressed with Levitt that he did that, and as a result of that, basically gave people the very things that allowed him to allow the mistakes to get found. Okay, so this is something from Ted Joyce's Restat paper, and he says this. He says, if abortion lowers homicide rates by 20 to 30%, which is what Levitt and Donahue found, then it's likely to have affected an entire spectrum of outcomes associated with well-being. It should improve infant health, child development, schooling, earnings, and marital status. Similarly, the policy implications are broader than abortion. Other inventions that affect fertility control and lead to fewer unwanted births, contraception, or sexual abstinence have really big payoffs. In short, a causal relationship between legalized abortion and crime has such significant ramifications for social policy, and at the same time is so controversial that we need more research on it. Okay, so that's what I did. I started the project in 2005, which was 3 years before that Foot and Getz paper was published. So I didn't know better that the literature was supposedly over. But I'm going to show you my paper, and then I'm going to show you that by exploiting all of the testable predictions from a theory, I actually show that my paper was probably wrong. Not for a coding error, but for another reason. Okay. So this right here is a picture that I had my friend Seth Hain. I commissioned him to draw this picture. So, so essentially, Einstein's theory of relativity had 3 predictions. One of them, I don't remember one of them. One of them was about Mercury's unusual orbit pattern, this like circle, this oblong oval. And then the third thing had to do with the space-time continuum or something like that. But basically what it said was light could be expected to move to appear to move. Well, actually light would move when it went around a large object. But what that meant was those large objects that were distorting the light, especially if it was light from a star, would mean that the position of the star in the sky would look different depending on whether you looked at it at night or in the morning. Now at night, the sun is way over here, okay? So at nighttime, this is the sun, right? That's the sun at night. And this is the sun by day, right? And the problem is by day, it gets so bright outside, that you can't see the stars. Now you could see the stars at night, and then you could measure the distances between stars, but during the day, which is when you need to take the measurements, you can't, okay? So they had an idea. It took about 12 years for physicists and astronomers to work out the testable predictions of Einstein's theory of relativity. And because it was all mathematical, I don't think Einstein is the one making the testable predictions. His was just working out from these equations the nature of time and space. So it was Eddington and Crommelin that worked it out, or one of them. I think it was Crommelin that kind of worked it out, and Eddington's the one that's going to do a study. So there was this very, very, very specific theory, and that very, very, very specific theory predicted that the stars would move at night. That was a very high stakes project, because at this point, I believe Einstein has already won a Nobel Prize, and he was internationally famous. So if they were to falsify his theory and reject that the sun had caused these stars to move, it would be a really big deal. Okay, Now, what they had to do is a plan, and they had as their plan the fact that the sun during the day can be extinguished during an eclipse. So when there's an eclipse, the entire sky gets black, and then you can make those calculations. So what they did, what Eddington did was he sent two teams out from England. One went to Brazil, the other went to Southern Africa, I believe. The Horn of something, I can't remember. And what they did, he had redundancies in place because he was worried about cloud cover. And it turns out one of them did have cloud cover, and the other one had a bunch of errors. The camera didn't work. But basically, they were taking photographs of the sky so that they could do their measurements later, and they did have enough data to do it. And in fact, Eddington, Einstein's theory of relativity, the prediction that he made was correct down to the most finest, because he had a very specific prediction about how large it would be, and it was exactly right. So I had the same kind of idea, all right? They had the same kind of idea. And I wanted just to tell you that, one of the things that you can do is, in trying to evaluate the parallel trends assumption, all right, so one of the ways to evaluate the parallel trends assumption, since it's not verifiable, you could look at things that shouldn't be affected by the treatment and check whether they're not affected by the treatment, okay? So that's kind of the idea of the triple difference. The triple difference uses a group like the higher wage group that shouldn't be affected by the minimum wage. So you want to have theories that make very falsifiable, very specific predictions, because if you have a very specific prediction, the burden of proof now shifts to the reader to explain why the omitted variable has the same kind of prediction. So there's this great paper by Coleman. I mentioned it earlier. It's in articles. It's called Causality in the Time of Cholera. It's about the 1849 and 1853 epidemics. And he says that Snow's rhetoric in those two manuscripts, the 1849 essay and the 1855 book, basically make this layered evidence of the following form. We should find effects where we find them around the Broad Street pump, and in Lambeth in the post-treatment period relative to the control group. We should not find effects anywhere where they weren't drinking the water, no matter how close they were, which is what they find when they go to the bar. In the brewery, they're all drinking beer, and so nobody got sick, okay? And then we're going to say, what kind of effects are we going to find? Okay, now that third one doesn't really show up in Snow's work, but it's going to show up in mine. And if all three of these are met, then your estimated causal effect becomes more believable, all right? So look at what I got. I came up with this theory. Hold on one second. Came up with this theory. We're going to do this, and we're going to take a break. All right, now what I have here is I got data from the Centers for Disease Control. All right, I got data from the Centers for Disease Control. And the data came to me in blocks of 5-year age bands. 15 to 19, 20 to 24, 25 to 29-year-old cases of gonorrhea. So my project was on gonorrhea because gonorrhea is predominantly spread by heterosexuals, and it's very common and easy to get, and it's associated with the high-risk, risky sexual behavior core group. Okay, so if you've got criminals declining, if you've got drug use declining, then it stands to reason that you might also have STDs fall, okay? Particularly if it's a group that's large enough to be affected by the early repeals, right? So basically what you have is, in the United States, you have two events that happen. In 1970, 5 states in the United States legalized abortion: California, New York, Alaska, Hawaii, and Washington. Okay? And then secondly, in 1973, the Supreme Court decision Roe versus Wade blanketed the whole country with legalized abortion. They ruled that the Constitution allowed for legalized abortion under privacy laws. All right? So that means we have 2 treatment dates. One of them is in 1971, once you allow for a, any kind of gestational spell. The other one's going to be in 1974, which is Roe v. Wade. Now, look at what I should find in the data. All right, when I run diff and diff regressions off of the repeal group compared to the Roe group for the treatment groups in the treatment categories. Okay, first is in 1985. A 15-year-old was born in 1970, a 16-year-old was born in 1969, and so forth. Okay? Should be the case that 1985, the 15-year-olds, none of the 15 to 19-year-olds were treated because with a 1-year lag, there was nobody treated in 1970. So when I do a diff and diff, or I do just a simple difference here, not counting the time. Well, it's going to be diff and diff by time, so it will be a diff and diff, okay? So we get 0 minus 0, that's going to be 0. So there's nobody treated in the repeal states, nobody treated in the Roe states, there's no difference between the two. So I should find no effect in 1985, but from 1986 to 1993, I should find effects because look, in 1986, one of the cohorts is treated. That's the repeal states, right? 1 minus 0. There should be a 1 age difference, or like a 1 level difference between the two groups. 72, 2 of them. 1987, there were 2 treated groups, 2 cohorts that are treated of the 15 and 19-year-olds. So that's a 2 minus 0. So now I get 1 minus, I get 1, I get 2. The effects are getting bigger. The effects get bigger here. And notice what goes on here. Now I have 4 ages that are treated in the repeal states, and I have 1 age that is treated in the Roe states. So that's 4 minus 1 is a 3. 5 minus 2 is a 3. 5 minus 3 is a 2. 5 minus 4 is a 1. And then notice right here, in 1993, there is no net difference between the two groups. So look at what, and then everything after that. So look at what the 3 things are. Where should we find effects? We should find effects from 1986 to 93. Where should we not find effects? We should not find effects in 1985 and after 1993. Right? Those are no effects. We'll find effects here. And then lastly, what kinds of effects? A U. There should be a parabola. Okay, that's the effect. There should be a parabola. All right, so what we're going to do is we're going to take a break. We're going to come right back in 15 minutes and finish up this paper. Let's go ahead and take a break.